Hi, welcome back to our channel. Macho is currently eating a chicken foot right now, and so he is a little preoccupied. That's his payment for participating in these videos. So, Macho, today we're going to talk about foundation, the chemical engineering aspect of foundation. And so, most people typically wear just one shade of foundation. Macho would wear about 3. So his foundation cost would be a little bit more expensive, but that's okay. But we really want to focus on what makes foundation different prices. And is it contributed to just marketing and who's endorsing it and whose brand it is? Or is it actually what goes behind the research and the actual care behind these foundations? So let's get into it. So first and foremost, when people think about foundations, they are trying to compare the differences between the two. So they're both liquid, they're both skin colored, they're both promising flawless coverage. So what's the difference? As a chemical engineer, I can tell you that foundation is one of the coolest everyday applications of chemical engineering that almost nobody talks about. When most people think about foundation, they think of it as a colored cream. But from an engineering perspective, foundation is a carefully designed suspension and emulsion. So what does that mean? I'm not going to pretend like I know fully what that means. So let's actually simplify it a little bit. So imagine trying to mix oil and water. They naturally like to separate. So now try to imagine millions of tiny solid pigment particles into that mixture. Those particles also want to settle to the bottom because of gravity. Yet, foundations stay smooth, spreadable, and uniform for months while sitting on a shelf. That doesn't happen by accident. Every ingredient inside foundation has a job. Water usually acts as a continuous phase. Oil helps with spreadability and comfort. Silicones create that smooth, silky filling, and pigments provide color. We also have polymers that help everything stay together, and preservatives help microorganisms from growing. That's actually something not a lot of people think about, nor do they even know it's actually in their foundation, but it's a super, super important part because it's important for your skin and it's important for your health. We definitely don't want anything funky growing in the bottle while it's sitting for months. So when cosmetic chemists formulate foundation, they aren't simply mixing ingredients together, they're balancing dozens of competing properties. So let's talk about this. Property is wanting desired result. So that includes coverage, spreadability, wear time, dry time, viscosity, shelf life, skin feel. All of these things are super important when it comes to trying to pick out a perfect foundation, because depending on what you want, you could want a different coverage level. So some people want a full beat on the first go around, but some people want a buildable foundation. And so that's kind of where those price points come into difference, where you have your buildables, which are not as hard to make as your full coverage foundations. But your full coverage foundations also might dry a little bit slower. So as engineers, we call this a multivariable optimization process. And the problem that we're having is that changing one property almost always changes another. So let's talk about the pigments. The color in foundation usually comes from iron oxides, titanium dioxide, and other mineral pigments. Here's where particle engineering becomes important. These particles are incredibly small. Their size affects how much light they scatter, how smooth they feel, how much coverage they provide, and even how natural they appear on your skin. If the particles are poorly dispersed, the foundation looks streaky or patchy. So when we're thinking about maybe our not as expensive foundations, you can definitely tell a difference when you're first go around, as you can see like streaks and patchiness, especially if you're one to use like a makeup brush and you start streaking. You'll be able to see that a little bit more than if you were using a higher priced foundation. But easily fixed, blotting is the key to that. But that's why manufacturers spend so much effort making sure pigment particles are evenly distributed throughout the formula. So the biggest engineering challenge is gravity. Gravity is constantly trying to ruin your foundation. Pigments are denser than the surrounding liquid, and physics says that these pigment particles should slowly sink. So why don't they? It's because engineers manipulate viscosity, and viscosity is simply a fluid's resistance to flow. So honey is really thick, but water is thin. So a foundation kind of sits in between honey and water when it comes to a viscosity scale. So by carefully adjusting viscosity using polymers and thickening agents, engineers dramatically slow the settling of pigment particles in that bottle. So that's why it doesn't separate as quickly. Another important tool is emulsifiers. Remember that oil and water don't naturally mix, right? Emulsifiers sit at the interface between oil droplets and water, helping keep everything stable. This is the same engineering principle used in foods like mayonnaise and salad dressings. So it's not the same product. We're not smothering, mayonnaise and salad dressings on our face, but it's the same concept behind it. And so whenever you look at a clear bottle of ranch, you can't really see that separation unless it's been sitting there for such a long time. And that's the same with foundation. So why do some foundations feel luxurious? So let's go back to the original question. Why does one foundation cost 5 times more? The answer isn't always that it's better. Sometimes you're paying for branding, but sometimes you're paying for sophisticated engineering. So yes, if you go to Sephora, a lot of those brands are endorsed or they are celebrity brands. Like Rihanna has her Fenty Beauty, which personally that's the foundation I use. I've also used Selena Gomez's Rare Beauty foundation, and it just got reformulated actually, and it's apparently a lot better for long wear. It doesn't oxidize as much, so that's super interesting. I haven't tried it yet, but yeah, there's a lot that goes into those into the engineering background of that. So premium formulas may invest in finer pigment milling, higher quality silicone elastomers, more advanced polymer systems, better manufacturing processes, tighter quality control. And those improvements can make the foundation spread more evenly, feel smoother, last longer, and appear more natural. And that's of course what the main goal of foundation is to look natural but to cover up some blemishes. So whether that's worth the extra money depends on the individual products. So for me, I want people to know, or I want people to be able to see that I am wearing makeup while other people want that no makeup look. And so it is up to personal preference when it comes to stuff like that. So what chemical engineers actually do, I think people hear chemical engineering and imagine giant oil refineries and other chemical plants, but the exact same engineering principles that are used for those products are the same ones we use for makeup products. And so we study fluid mechanics, transport phenomena, particle technology, mixing, rheology, and process design. Those concepts don't just apply to industrial chemicals. They apply to makeup, to shampoo, sunscreen, toothpaste, even your morning coffee. So the next time you pump foundation into your hand, remember, you're not looking at colored cream. You're looking at a carefully engineered material designed to balance chemistry, physics, manufacturing, and consumer experience all in one tiny bottle. And honestly, I think that's pretty amazing. So I hope you enjoyed this video. I know I was looking at my notes a lot, but this is the first time I'm doing a video like this, so hopefully I'll get a little bit better, but I hope you enjoyed. Thanks.